You are listening to The Vocal Technologist. Spoken tech for your ears.
Welcome in. You handed us just a huge collection of updates, articles, and research on modern infrastructure. I mean, everything that keeps DevOps and platform engineering moving at, well, light speed?
It's a lot to get through.
It is. So our mission today is pretty simple. We're going to be your expert guide, cut through all of that, and give you only the most impactful, surprising, and business-critical knowledge.
That's the plan. And looking at everything you shared, there are really three massive trends that just jump out. These are the areas getting the most attention and probably the most budget right now.
Okay, what are they?
First, we have this unstoppable movement to make cost management a core engineering problem, not just, an accounting review. That's FinOps.
Right.
Second, the urgent need to put security guardrails around this new frontier of autonomous AI agents in production.
That's a big one.
And finally, some absolutely critical stability and safety updates to the foundational layer, Kubernetes and all the tools around it.
Okay, let's unpack this. We should probably start where most companies feel the most pain.
The cloud bill.
Always the cloud bill. I find this whole FinOps movement so compelling because it seems to be fundamentally changing developer psychology. It's stopping us from treating cloud spend like this mysterious, uncontrollable utility bill.
Yeah, and instead it makes cost efficiency a measurable aspect of system quality.
Right, alongside performance and reliability.
It's a necessary mindset shift, truly. I mean, the best examples in the material show companies like Duolingo integrating financial awareness really deep into their engineering workflows.
So it's not just about, like, a weekly cost meeting.
No, not at all. It's about making that cost data visible inside the tools developers are already using. Think about embedding a dashboard right in a deployment pipeline.
Or even showing the projected cost increase of a change directly in a pull request.
That's the dream. That is accountability shifted left.
But hold on, isn't asking engineers to worry about the bill just adding more cognitive load? How do we balance that efficiency demand with, developer velocity?
That is the friction point. And the answer is better tools. Tools that provide specific, non-abstract data. For example, let's look at storage.
Okay.
Datadog Storage Management now gives really fine-grained visibility into Amazon S3 costs. The visibility has reached the what they call the prefix level breakdown.
For those of you who might not live inside AWS buckets all day, what exactly does prefix level breakdown mean in, practical terms?
It means we're no longer just seeing a massive line item for S3. The prefix is essentially the start of the object key.
Like the folder name.
Exactly, which often maps directly to a specific application, team, or workload. So knowing the prefix lets you attribute that spending directly and accurately to the team that's responsible.
So it moves the conversation from storage is too expensive to Team Alpha's data retention policy for this specific log bucket is costing us $5,000 extra this month.
Precisely. It makes accountability direct and immediate.
And the tooling is actually providing actionable advice too, right? It's not just a report.
Exactly. Those systems aren't just reporting on the past. They're recommending proactive cost-saving actions. For instance, recommending moving specific cold data sets to lower-cost tiers like Amazon S3 Glacier.
And the savings can be pretty significant.
Oh, yeah. The potential savings cited are thousands of dollars monthly just by optimizing the tier your data rests in without affecting how the application operates at all.
Okay, so shifting from storage efficiency to processing efficiency, let's talk about the databases behind all this, Postgres specifically. One of the items flagged a really insidious performance and cost sink, something that often goes completely unnoticed. Index bloat.
Index bloat.
Yeah.
The silent performance killer.
It is.
The complexity here is that for a long time, the advice was, just index everything.
Right.
But keeping your index set lean is just so critical for system health.
Because intuitively, more indexes should mean faster lookups, right?
They do help reads to a point, but they severely punish writes. Every single insert or update transaction has to update all those indexes. As they pile up, writes slow down dramatically. But the damage doesn't stop there. Extra indexes waste valuable disk space, they increase planner overhead, and crucially, they compete fiercely for cache.
I hadn't thought about the cache competition.
It's huge. If your cache is full of rarely used index data, it pushes out the actual data and the frequently used indexes you really need for fast reads.
Yeah.
Which leads to this massive counterintuitive read performance hit.
So a bloated index isn't just a storage problem. It's creating this cascade of performance bottlenecks, slower writes, poorer reads, increased CPU. The lesson for every platform builder is pretty clear then.
Yeah, optimization is about maintaining fast, healthy performance. And the financial accountability is just the measurable byproduct of that good engineering.
Well said. Speaking of proactive accountability, let's look at the biggest new risk vector we have to defend against, the autonomous AI agent. We're seeing this acceleration of bringing agent code that acts on its own into live production environments.
Yep.
What are the security implications there? I mean, when you give an agent the power to modify your infrastructure or your code.
That's why security guardrails are no longer optional. The material highlighted Google's introduction of the agent Sandbox on Kubernetes and GKE.
Okay.
This is essentially a new primitive within Kubernetes, specifically designed for secure and highly scalable agent code execution.
And to make an AI agent isolated enough to trust, the solution relies on some pretty deep technical components like gVisor and Kata Containers. For those of us who haven't spent time configuring those, what's the single biggest win that isolation gives us when an AI agent inevitably makes a mistake or gets hijacked?
The win is containment, pure and simple. Both gVisor and Kata Containers offer strong kernel-level isolation, but without the heavy overhead of traditional VMs.
Right.
This means if the agent's code goes rogue, say it tries to access unauthorized files or network segments, it is confined instantly to its own tightly controlled environment. It's like creating a safe, hardened playpen where the agent can run, fail, or be exploited without taking down the entire cluster.
Or accessing production secrets.
Exactly. It's intelligent risk mitigation.
You mentioned performance is also key for these agents. They need to spin up and execute quickly.
Absolutely. Security often comes with a performance penalty, but here they've optimized heavily using pre-warmed sandboxes and something called pod snapshots.
Pod snapshots.
Yeah, it allows Kubernetes to save the state of a running container and then quickly restore it. It eliminates the typical latency you'd get from starting a new sandbox process from scratch. It's essential for high-throughput AI workloads.
You know, what's fascinating to me is that AI isn't just creating a new security vector, it's also being used to secure traditional code bases.
That's right. We see tools like Datadog leveraging their Bits AI to filter out false positives in static code analysis.
Oh, that's a lifesaver.
It is, because static analysis is vital, but it often generates so much. Just junk. Alerts that are technically correct but practically impossible to exploit. By classifying vulnerabilities as likely true for false positives, the AI dramatically reduces the cognitive load and fatigue that developers face during triage.
So more time fixing real issues, less time chasing ghosts.
That's the idea.
Okay, so if we're scaling these sophisticated agents, which require specific isolation and maybe GPU resources, what does this increased complexity mean for the platform teams who have to deploy and manage them? Is this just MLOps rebranding, or is there a fundamental difference in the tooling here?
It's a huge difference, primarily in the velocity and standardization required. Traditional MLOps often bottlenecked on bespoke infrastructure setup.
Right.
Scaling generative AI requires platform engineering to step in and build a standardized internal developer platform, an IDP. And the key difference is that the IDP must provide a paved road for self-service LLM deployment.
What gets paved over? What's being abstracted?
The complexity of managing the specialized underlying infrastructure, the GPUs, the networking, the scaling mechanisms. The IDP uses tools like HTTP Terraform, GitHub Actions, and Port Feared to abstract that all away. It presents developers with a simple interface where they can deploy their model without knowing the precise Terraform or cloud configuration underneath.
It's all about that separation of concerns.
It is. It lets developers focus on the model and platform teams focus on the reliable, secure delivery mechanism.
That makes perfect sense. Okay, let's shift our attention back down to the core infrastructure layer. Kubernetes itself. Our material flagged a critical security and safety risk that, honestly, is astonishingly easy to overlook.
Yeah, because it's such a tiny configuration detail.
I'm talking about the danger lurking in your Kubernetes context.
The infamous single line in your .kube config. It is terrifyingly powerful
It really is.
because that one line determines the default cluster targeted by every kubectl command you run. If, for even 5 minutes, that line is pointing to your production cluster and you run a cleanup script meant for dev,
Oh, no.
you have created a catastrophic event with one careless keystroke.
It's the dreaded default configuration that guarantees a mistake when you're tired on a Friday afternoon. So what's the safe pattern? What should everyone be adopting immediately to avoid this fat finger deployment?
The safer practice is to absolutely never rely on a global context pointing to production as the default. Just don't do it.
So what's the alternative?
Keep only the development or sandbox configuration as your default. Then, if you need to perform a risky action against production, you must explicitly switch to it by setting the kubeconfig environment variable.
And you do that with a shell alias or something?
Yeah, often a shell alias or a custom environmental setup.
Okay, but why is setting the environment variable inherently safer than just relying on the file default?
Because it forces the risk to be visible and manual for that specific shell session. When you rely on the file default, the production context is implicit. It's hidden.
Right.
When you explicitly set kubeconfig path to prod.yam, you are making a conscious, intentional choice that is temporary and explicit. You are signaling to yourself, I am now operating in a high-risk zone. It's applying security principles directly to your workflow safety.
That's a lesson in workflow hygiene right there. Okay, moving beyond configuration safety, what about reliability and core ecosystem updates?
We've seen major steps to solidify the platform. AWS Backup now supports Amazon EKS.
Which is huge.
It's huge because it provides a managed agent-free solution for backing up your cluster states and critical application data. It simplifies the complexity of EKS backup into a single service, a massive win for standardizing reliability.
And we have to mention a big birthday for one of the most critical tools in the cloud-native space, Helm.
Yes, Helm is marking 10 years with the arrival of version 4. This update enhances deployment capabilities significantly, bringing improved SDKs, a modernized plugin system, and better support for multi-cluster and sophisticated CI/CD workflows.
So it keeps the core experience familiar, but adds the plumbing for modern delivery.
That's a great way to put it.
Finally, let's spend a minute on the infrastructure as code landscape. The material suggests we're moving firmly toward a polyglot strategy. Organizations are stopping the search for one tool to rule them all.
And starting to align the tool's strengths with the specific layer they're building. Yeah, that polyglot approach is the mature strategy.
We have three main players right now: Terraform, Pulumi, and Crossplane. Let's break them down.
Okay, so we need to contrast their operational models. Terraform is the incumbent. It's best for broad, multi-cloud management and traditional CI/CD pipelines, relying on its domain-specific language, HCL.
In a central state file.
And a central state file. Then you have Pulumi, which feels much more like a software engineering tool.
Right.
Pulumi breaks that HCL barrier by letting you define infrastructure using standard programming languages like Python or TypeScript.
Right.
This really shines for highly dynamic infrastructure.
So if you need to build infrastructure that auto-scales based on application metrics or involves complex conditional logic,
that's Pulumi's sweet spot. It integrates beautifully with standard software practices, testing, and IDE tools.
And finally, Crossplane, which approaches the whole problem from a Kubernetes perspective.
Crossplane is fundamentally different. It operates within Kubernetes, using the control plane for continuous reconciliation. Instead of running a plan and apply step like Terraform, Crossplane ensures the desired infrastructure state is always maintained. It corrects drift automatically.
Which makes it exceptional for building internal developer self-service platforms, doesn't it?
It does. The goal is to present underlying infrastructure components, like a database or a network endpoint, as native Kubernetes resources that developers already know how to manage.
Wow, okay. We've covered a huge distance here. We navigated how to reduce costs and increase quality by shifting financial accountability left with FinOps and S3 prefix visibility.
We looked at how to secure the future of autonomous systems with the agent Sandbox, built on Kata and gVisor isolation.
And we stabilized the present by mastering Kubernetes contexts and leveraging modern tools like Helm 4 and agent-free AWS Backup.
And if we connect this all to the bigger picture, what's evident is that the line between finance, security, and core engineering is it's utterly vanishing.
It really is.
Knowledge of all three areas, understanding cost impact, containment, and system stability, is now, I think, mandatory for every developer and platform engineer.
We hope this knowledge shortcut helps you navigate the platform world, maybe even helps you out on your next vocal technologist project. Okay, let's leave you with one final provocative thought to consider.
I'm ready.
One of the items we analyzed noted that AI coding tools can produce about 70% of a solution extremely quickly. But the crucial observation was that trust is declining for the remaining 30%.
The hard part.
The really hard part. That remaining chunk covers edge cases, security hardening, production integration, all the tricky stuff. This raises an important question for you. As automation takes over writing the initial code, Will the most valuable human expertise soon shift entirely from the creation of code to rigorously reviewing, integrating, and maintaining accountability for the reliability and safety of the code the agents produce?
Something to mull over.
Indeed. We'll talk to you soon.
Spoken Tech for your ears.